Hi everyone. In this problem statement, we have to find k pairs with smallest sum. So we are given two integers array num1 and num2 which are already sorted in non-decreasing order or ascending order. So let us take we are going to have num1 1 7 11 and nums2 which is 2 4 and 6, and we have to find k pairs or 3 pairs which are going to have the smallest sum. So right here, if you try to understand the problem, right? So one way would be to find all the values like 1, 2, then 7, 4 in that way, right? So what would be the possibilities? Which would be 1, 2, 1, 4, 1, 6. So this would be the smallest values because you already know, right? Because 1 and 2, right? This is the one pair which I am 100% certain is going to give me the smallest value. The reason being because it's in ascending order, right? So adding these two will always be the smallest number. So that is the idea. Then if I do a brute force, right, it would be 7 2 7 4 7 6, and then 11 2 11 4, then 11 6. So this would be the result, right? Then I have to add those values, take this sum, which is going to take a lot of time, and the time complexity would be very bad because I need at least k pairs, right? So what's the point of doing a brute force and calculating all the sums of the pair? So the idea is that what we're going to do, we are going to for the value that we are 100% certain, right? So we are going to take this pair and put it into heap queue. So let's say this is our going to be our heap, and we're going to take a sum. So it would be 3, and the value would be we're going to put the index. It would be 0 and the other one would be 0. Okay, then I can take either of it. You can take it from, we can take this static and do like 2 7 in that way. In this case I'm just doing it like the second one would be 1 4, so it would be 5 0 and 1, and then 7 0 and 2. So out here, right, the smallest value is 3. So what I'm going to take, right, and I'm also having a look into my key. So I'm going to have the result, and result, right, I'm going to take this value 0 0, which is basically corresponding to 1 and 2. And from here I got the index, right? The second thing that I'm going to do, right, I'm going to increment. So when I'm popping this out, right, I would say whatever value means I'm going to get I and j, right? So I was static earlier, so I'm going to say take I plus 1 value and j and add it to our main heap. So what would be I plus, so it would be 7 plus 0, which would be 9. So it would be 1 and 0. So we are going to get that value. Now we popped it out. The second one is going to be 1 and 4. So again I plus 1. So I plus 1 would be 7 plus 4, which is going to be 11, and it would be 1 1. We pop this out. Then we are going to take this 1, and its value would be 1 and 6, and at the same time we would keep on decrementing the counter. And here, right, it would be 11 and 2, which would be 13. So it would be 2 and this is 0 2 and 0. So in this way, right, if it was required to get 6 element, we can get 6 element or if it was required to get 9 elements, so you're going to get those values. So here, right, once the k is 0, right, I can return the result. So that would be the idea how to solve this problem. So here, right, instead of doing through a brute force, we are, for the values we are extremely certain, right, that is going to give the minimum pair, we are going to add it to heap q. And in case, right, in this case it was pretty, like, number was keep on increasing, right? But in case the number was not increasing, what if the value was like 1, then 2, and then say 20, and on the left side, right, the value was 2, or instead of 2, right, let's say 40, 50 and 60, right? So, and we have to take the 6 pairs, so it would be 141, 51, 61, 42, 52 and 62. So in this case, right, so you can understand, right, how it is looking, or you can look into the cases, right, where it is going to fail if I'm doing it through a normal sorting way or through a normal brute force way. So this is why we require a min heap. And min heap, right, if I look into the time complexity, it would be k log n. So log n to add the values, and let's say if there are k pairs, right, it would be k, and again to pop out element it would be a log n time complexity, but I'm just giving a estimation of the time complexity of this type of problem. So that's all. Now let us jump to the Python solution. The first thing we need to do, right, we have to import our heap queue. So I can say import heap queue, and then let me create the result and also our min heap. So I'm going to loop through the elements. So for I in range, let's say 0 to length of nums2, and here, right, I'm going to add it. So heap q dot heap push, and I'm going to say min heap comma the values that we are going to add. So it would be nums1 of 0, because we're going to take the num0 as static for now, and nums2 of I, and we are going to also pass in the current index of num1 and num2. So num2 is going to keep on adding, and the num1 is fixed for now. So now I'm going to write a while loop. So while k is greater than 0 and we have element in min heap. So min heap. So the first thing is, let's say what is the current sum, and get the I and j. So it would be heap q dot heap pop, and we are going to pass in min heap. So once we get that, right, we are going to add that to our result. So result dot append our nums of I and nums of j. Similarly, right, we are going to do it till so, and we also had to add those indices, right? We're going to increment the I to add that value to our main heap. So if I plus 1 less than length of nums 1, so till that, right, again we are going to say heap q dot heap push, say min heap, and we're going to pass in nums1, and here it would be I plus 1 plus nums2 of j, and the indices are going to be I plus 1 and j, and at last we're going to return the result. Let me run the code. I hope it should work. Yeah, I think I forgot to say nums1 and nums2. So because there are two different arrays, so let me run it again. Saying wrong answer. Okay, I forgot to do one more thing, right? It has taking the all the elements. So I have to do till, I have to decrement the k also. Means once I add one pair, right? So I have to decrement the k. So let me run it again. So now I hope it get accepted. So both of the test case pass successfully. Let me submit the code. So the code submission is successful. It is saying beating 9.95. If I run it again, I'm pretty sure I'm going to get a better result. Last time when I did right, I was getting a result of 60 or something. I don't know what changed. Let me try to run it back again. Not sure what is the issue, but I think in this way you can solve this problem. And this is going to be pretty much efficient solution. That's all for this video. See you in the next one.